Sometimes you have to take it till you make it, no?
Yeah. No, I mean, seriously, if you know somebody or you think you have done, very good GenAI experience hands-on, right? That's what I'm saying. You don't have to wait for the modules. It's so easy right now that everybody can get started. Build 3 or 4 good projects and have the confidence and the conceptual clarity of, what you've done, why you've done, right? And explain that. So it's not really like anybody's born with that knowledge. Everybody's acquiring, right? GenAI was not something that we knew, let's say 2-3 years back, right? So, like, I mean, till the ChatGPT came in, nobody knew. Like, I mean,
White coding.
yeah, vibe coding.
White coding only, right?
Do the vibe coding create the projects?
4-5 GenAI projects. I thought things will turn upside down. Things are changing, but people are not changing. That's right. So, because 4-5 projects. Oh, or you want to learn?
Don't wait for the module to be over. You don't need any module, any deep learning, any reinforcement learning, none whatsoever. You don't have to wait for my machine learning also. You can build your own GenAI app today.
Yes, today.
Today you can build it.
Examples in Git, right? Git repositories are amazing resources for you to copy shamelessly. Just copy shamelessly.
Exactly. Customize it.
Why? Why are you coming from some moon land or Pluto land or something? You don't copy, you are completely genuine. We're all basically copy, DNA four chromosomes only.
Yeah.
I mean 4 types only. They are copies of each other. Right? So you can't say I will never copy. No? You copy, right?
Absolutely.
Copy smartly. Or you are waiting for 2 years and then another 2 years. And
No, that's not a good strategy. Don't wait. Don't wait. That's what if you take one biggest thing from all the mentoring so far, don't wait for any module. You don't need any of those knowledge. I mean, they'll be good for you to really build the background and like the good foundation and the concept, but you should not wait until the entire program is over. Then I'm going to create my portfolio. Then I will be more confident. Then I will start to go in the repeat market. Nope. Do it now. You know enough already.
there are 2 equations you should know. Linear regression equation, straight line fit. Then you should know logistic regression equation. Can you explain that? Can you convert 1 into 2? Linear to non-linear? Non-linear to linear? Is it possible? Right. No. See, they studied the entire thing. That's
Well, I think they can explain. Let's see who can explain.
Who can explain?
Who can explain the difference between a linear and a logistic?
What is the formula?
Raise your hand. Don't be afraid of to do.
I can explain.
Huh?
I can explain.
Yeah.
No, you can explain, but I don't want you to be explaining everything.
But you know that in logistic regression, there is a linear regression inbuilt. You know that, right?
Yes.
And what
Who can explain? You were not there last time.
Last class, therefore I don't know this equation. This is 7th standard, 7th standard, 8th standard.
Linear is continuous and we get the value continuously like independent of variables. But logistic is the probability. It is for category.
Not clear.
So when we plot a graph, the linear will be like a straight line. And
What's the
non-linear
formula?
straight lines.
What's the formula? Explain each component, understand, right? There is an intercept, there is a slope, there is a bias, there is an error, there is a line. How all these things fit in?
I think Santosh can explain.
Yes, the linear.
He takes very good notes, by the way. Awesome. And that's one of the things, one of
He's good marketing. Arpan is very good in doing and marketing. Right? You must learn that.
I'm
You must
I'm
learn.
giving other feedback to Arpan that try to be short. Because when you're trying to explain something, be very, very to the point.
Maybe you'll learn the trick of
Yeah.
marketing. Right? This is called punchline,
I
tagline.
want to build my own brand. Like Ram sir. Yeah, I have done. Can I explain it?
Yeah, I think.
But I thought you are going to this because you are saying that if you these are two fundamental concepts on which the entire Gen AI, entire LLM, everything is built on that. If you look under the hood, right, you can explain that. Then you know classification problems. They see for grouping there is a little bit of different equation, but otherwise these are fundamental stuff. No, deep learning also finally will get into a logistic regression equation. Anything you do finally you have to come to that, the final end, right? You predict a number, you classify a class, right? Or you group. That's all.
Yep. If you are a practitioner of Gen AI, right? I mean, it's not necessary for you to know linear algebra or anything else for that matter, right? If you're a practitioner, you should know what tools are available, what services are available, how do I leverage them, and how do I build a solution around it, right? Which will be 95% of the population out there, who are just practitioner. They're not necessarily researcher. Now we have other side of people like Arpan who are researcher. For them, it's really important to go in the mathematics behind that and come out with a new sort of model and all of that. But most of the companies do not need researchers right now. They need maybe one or two researchers. We need practitioner who knows what exists out there, do the vibe coding, use Cursor, use Windsurf, use GitHub Copilot, get things done, create the dollar impact. Remember, very first day I said machine learning is dollar impact. Your fancy statistical linear algebra knowledge doesn't count for anything unless you can show the dollar impact, right?
Gen AI pipeline, you can't stay under the rocks, no? Right? What is that Gen AI would do? What is the pipeline? Again, you need task has to be defined, goal has to be defined, your different components has to be done. It's another package, LangChain or QA, whatever is another Python package, right? And then you have a corpus, you have a task to be done, read a document, act on something. That's another agent, right?
Yeah, absolutely.
Why you
How many have started doing something in Gen AI right now? Anything at all? Not you. Others. Karthik, you've done something? Huh? Huh? Okay. Jira metrics. Yeah. Anybody else? Then we'll hear from Arpan as well. Yeah, Ajit. Yeah.
Defining the model, why setting needs are finding out which features are.
What is stopping others from trying it? Let me ask that question. Why didn't you try so far? When it's so easy. Anybody?
It must be an exciting, running and building one project.
How many of you do the vibe coding?
No?
No, not for the assignment. For the other things. Huh? Other things? What have you done, Deepika? Hmm. 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 Right.
That is one thing, and also.
But you can create a parsing engine, no? You can create an entire parsing engine, use just one resume at a time. Put 10 resume at a time, the fields can be kind of created.
Yeah, in that, can be attached to one, and then that will be sent to the API. Call that I have done, and also job description. If you give the job description, it gives the output like matching profile, listing the matching profile.
That's great. That's great. Yeah. Good. Anybody else has done anything in the vibe coding? Yeah. Vedant? Louder. You have very soft or very low.
Those who make noise will be heard, no?
Yeah, louder.
So we are building a legal module wherein which, let's say for example, the person is put in the case, let's say a dispute between two companies and other stuff. So we are trying to kind of, so currently what the phase it is in is that whatever the orders which come from particular jury and other folks in the US especially, we're trying to evaluate that in case if we're trying to put our case in front of let's say judge X to Y.
Mm.
So what is the probability of our winning the case? And also it has some extractions where we give, like, for example, what kind of law were applied, what is the change in the laws and other stuff. So that is something which
So somewhere related to what Granicus does, they are into our government.
We're all in the government sector, yeah. That's right, yeah.
You're not planning to apply?
Yeah, why not?
I'm already,
You can always apply. There's nothing stopping you.
Yeah, whether you join or you can
Yeah.
apply and see whether you will be.
Yeah, exactly.
Nice.
I just got a job.
Oh, congratulations then.
Congratulations, yeah. There's some good news. Abhi, he got a job. You should,
I knew him, so asked him.
Okay, okay, got it. So the main takeaway, folks, is, I mean, there's nothing stopping you, right? So, yeah, go ahead. Your name tag is not correct, I believe, no? Or is it? Not there, na? Huh. Huh.
APB, Agentic Project Builder.
Hmm.
So there's a flow to create a project before you start working on that.
Yes.
So you create your camera ID, basically the application ID, and then you create your Jira project, then your GitHub repository, then you grant access to internal employees.
Mhm,
All these steps are there.
mhm,
Apart from this, some diagrams are generated. You have to get some architectural reviews.
mhm,
So these sort of issues, and then cybersecurity accounts you have to create.
mhm.
Check marks, Nexus, and all that.
Yep.
So this entire thing we are doing via MCP. We are creating MCP servers with each of the like application individually.
Yep.
At organization, at the organization level.
Yep.
But our team is working on to integrate everything and create one particular platform
Mhm.
to do this entire journey with from 15 days to, like, let's say 1 day.
Yeah, absolutely.
Like,
So what is the text statements?
the LangChain, LangGraph, Open API, we have the subscription. We are using that.
Apply. Right? You are applying. Okay. Right.
And then
He is very happy where he is. You mentioned EY or which company you're part of?
Visa.
Huh? Visa, yeah, Visa, yeah.
Yeah, Dishani there. Dishani.
This Sunny, yeah, the previous batch, yeah.
Someone was there in the last batch, last week.
Hmm. Okay, Arpan, first to your GenAI story and then explain this one.
GenAI, not much.
But keep it short, huh?
Yeah. No, it is very simple project. So in our project, we have lot of help files. So customer used, whenever a new customer use our application, so they used to see all the help files. Then if they have any doubt based on the help file, they just learn how to run this application. So we are creating one chatbot.
Hmm.
And our application is related to many other applications also.
Hmm.
So there are many utilities and same thing, whatever we are doing, they also do the same thing, same code. So for that, we are creating MCP servers, tools,
All the good work, yeah.
all these things. But frankly speaking, I am not getting interested. So I'm running behind them
Hmm.
because our application is linked with IBM. So I'm telling
Okay.
them IBM has developed what's the next, why we can
Oh.
create our own model
So next.
without any GPT model create. So
Excellent.
they are not ready, but I am pushing them.
Okay, awesome, great. Now explain this one. Let's see if we can do it, yeah.
Confusion.
I was asking this same confusion matrix during my interviews, and 8 out of 10 people will not be able to explain how the recall is completed. So let's see if we can do it.
So this sample numbers.
Hmm. But why your text goes like this? It's like taking off. Go ahead.
So this is my sample numbers.
Ah.
58, 10, 29, and 32.
Hmm.
So these columns of our prediction. This is prediction of first prediction, the second prediction. Okay, and these rows are actual value.
Sure.
Now this is zero. Zero means zero case means
Yeah.
false and true. Zero means false and true, like that.
Mm-hmm.
Now I am calculating the recall.
Hmm.
Recall means among all the actual zero,
Hmm.
how many my model has been identified. So actual zeros are 58 plus 10, 68.
Hmm.
Prediction is 15. Model is identified 58.
Hmm.
So 58 by 58 plus 10.
Is everybody clear? Any doubts on this one? Are you agreeing or disagreeing with Arpan? Correct? Okay, great.
So
Carry
it is
carry on.
0.85, 85 per my recall for 0 is 0.85 or
Mhm.
85%. Precision means among all the predicted 0, how many my model correctly predicted at 0.
Hmm.
So this is my prediction, 0 prediction for 0. Total is 58 plus 29. And how many correctly predicted is 58. So 58 plus 29, 58 by 58 plus 29, it is 0.66.
Any questions? Is it clear? Everyone? All good? If you're not clear, let us know. We'll be more than happy to explain again. But and also I'm maybe tricking you that this is correct. So you have to keep us honest whether this is correct or not. How many of you say it's correct? Raise your hand.
The recalls numerator is true positive.
Recalls numerator is true positive. Explain what you mean. I mean, are you saying it's wrong or correct?
Positive by divided to positive is false positive. So
First of all, are you agreeing that the marking is correct or the labeling is correct? True negative, false negative, true positive, false positive. How many of you are agreeing, disagreeing? People who are agreeing, raise your hand. Most of you don't have any views. Okay, it's correct.
I'll explain why it is negative means.
Let's others also jump in first. Yeah.
target is to predict that
One.
one is positive,
Yes,
two and false.
that's right. That's right. Yeah. So target is to predict positive, and then the other classes are negative, right? Is this clear? True, positive. You're clear? And then you're clear with the recall definition, or you still have a doubt over here? So I'll say do not compute the recall by the definition of the true positive, false negative. Don't follow the formula. Follow your intuition. How Apan was explaining, right? So what is the recall? The recall is from my actual total positives. From my actual total positives, how many of those are correctly identified by the model? So how many total positives we have? 58 plus 29. Sorry, I'm looking at the wrong axis. So this one. Which one is your actual?
This is actual for 0, actual for 1.
Okay, so you're computing for the actual for 0. So 58 plus 10 are the total actual. Out of those, we are correctly identifying 58. So the recall for 0 is that number. Is that clear? Yeah, carry on.
So now, recall for 1, same. How many among all the actual 1, how many my model identified, correctly identified? So for actual 1 is, this row is for actual, 29 plus 32. Okay, model predicted, this row is for prediction, for this for 0, this is for 1 works. So 29 plus 32 means 32 by 29 is plus 32. 32 plus 29 plus 32, it is 0.52. My recall for 1. Precision is among all the predicted 1. How many my model correctly predicted? That is 1. So this is my prediction. 30 total prediction 32 plus 10 means 42, and actually 32 is the
Correct.
1 correctly.
Yeah.
So 32 by 10 plus 32, it is 32 by 42.76. Now here accuracy, I am calculating total means how many total correctly identified is true negative, that is also correctly identified by model, true positive, that is also correctly identified. So true negative plus true positive by all. So it is 0.69 is the accuracy. And this is like, okay, shall I explain this why I have written two negative, two positive, false positive, two positive and false negative?
Sure.
Okay, so here in this case, actual is 0 and prediction is also 0. So my model is correctly predicted, it is negative. So it is 2 negative. Here it is 0 and 1. So my actual is 0 and my model predicted is 1. So falsely predicted 0 as 1. That is called falsely positive, false positive, because falsely it is predicted as positive. In actual it is negative. Now here false negative. Why false negative? Actually is 1 by model falsely predicted as 0. So falsely predicted as negative. So, and when actual it is positive, so it is false negative. True positive means actual it is positive, model also it is predicted as a positive. So that is true positive. Now, insights is accuracy also not good. And my model here we can see my model recall is 1 because is 0.50 to 0.52. My model is failed to predict lot of correct positive cases. So that is why my model is not good. Accuracy also not good. Recall is also very bad, is 0.52 because it is failing to model is failing to identify positive case. Recall is 1. So it is not good model. Here also recall is sorry. Yeah, precision is also 0.66. So overall model is not good.
Okay. Any questions, doubts, people from anyone? All good? Okay, thank you for the first presentation. Anyone who would like to come and write very fast the 6 steps in a modeling process on the board? Any volunteers? All the 6 steps in a typical modeling flow. No. Others? Yeah, come. Huh? Okay, you can follow the roads. Yeah, come. You went to the 4th floor? So you can erase. Is everyone good with this? Shall we raise picture? Huh? You want to take picture? You can take a picture. Right. Okay, so but this is something different. Yeah, yeah. Thank you, Rakshit. So this is good. I mean, this is the overall flow for how you do the modeling, but let's say you decided to build a model. I'm talking about that 6 steps. Who would like to come into it? Come. Huh?
And just tell from here.
No, I think it's better you write it. Because after this, I'm gonna go really fast on all the other techniques, right? So if there is any underlying doubts from anyone, you better clarify now. Today's a 3rd class, right? Yeah. So we have 5, I think. So including today, we have 3 more.
It's right here.
Yeah.
This is a capital X and Y. Redundancy. Second one is we have screen. The scale. Then we use the log function. Log, like it is a classification. So this is the creation of that instance of the algorithm modulation. That number will be fit the model.
So this is where we give all this data to the model to create the line of curve model. And then we predict. And the last one is means.
Great. Any questions, thoughts? Is it clear? All good?
Yeah.
Yeah.
With this data separation and then fitting transform on the data. If it is for the test data and do the log transformation for the fixed report. Then you find out the coefficients also. And I'm quite confused, I'm not sure. The coefficients of their gender and the BMI are almost same. So, but the BMI has a more impact of, because both cannot be measured on the same scale. So how we should then draw the inferences out of those coefficients when two coefficients are similar.
You're saying for the linear regression work that you've done? So have you done the scaling on that? Okay. Maybe share your model. Does the coefficient for BMI and gender, I mean, are they equal for you? They're not. So just share your model then, because I would expect them to be different. BMI has to be a lot more important than the gender for the insurance protection, right? Now, if you haven't done the scaling, that might be the reason. So that's where, I mean, so I'll come and double check your work then. Yeah. Yeah. Okay. Fair enough. So let's continue then our journey. So we're going to build our first model today, and this will be on Titanic data, right? Huh? Which URL? The position? Yeah, I can share that.
Check if I.
Yeah.
So when you say generative AI, we are just saying consuming those APIs, right?
It's more about like building, evaluation, LLM, fine tuning, all of those things, right? So the JD says, what are some of the things. So see how many boxes you check basically. Or if you don't, like you have anybody else who is a good fit, recommend them also. So my team only does Gen AI work, right? I mean, we're not doing any of this logistic regression decision tree for now. But like, when I was in a banking, Citigroup and some of the other fintech players, I mean, that's where these models will really come in, right? But right now, the entire scope of things is more about the chatbot and the Gen AI and all of that. But like I said, I mean, we're not doing cutting edge research. Like, is this the right LLM, or how do I really get the best performance from the LLM and all of that? So we are more the application oriented, and 99% of the businesses will be application oriented, right? Knowing a model, making the LLM API call also is very, very easy. Building a POC is also very easy. What is hard? Taking that POC into the production, having the cost, having the latency, having the performance in the production environment when thousands of calls are coming in, right? That's where the challenge is really. So it's not so much about knowing the algebra or the math behind that. It's not so much about knowing what tools exist out there also. It's more about how do I bring it all together? Think about like an architecture, right? What makes really sense, right? What type of data I should be, working with? How does the data really come in, right? How do I really make sure that I've done the right, like chunking? How do I do the right vector DB search? How do I optimize the performance, right? That's where basically it all comes together, right? So it has to really create the impactful solution. So let's say if I build a chatbot, you log in and you're waiting for 30 seconds to get a response. Right there, it's a very negative experience, right? So no matter how accurate your chatbot is, I mean, just because it's lagging in the performance, it's not going to have a repeat usage, right? So those are some of the things where basically rubber meets the road, right? So, and that's where we are actually optimizing things. Yeah. So moving on then. We will begin with our model for today, which is a logistic regression model. We've already spoken about the conceptual underpinning last time. So I think everybody's clear. And this is going to be your article number. Am I talking here in this one? Which one? I mean, which one you're hearing? Is it from RP or something else? From my system. Okay, then I can be a little bit softer, otherwise I have to shout. Yeah, so that's good. So we are looking at the article number 31. So I believe classification metrics are clear, everyone? Precision, recall, accuracy, and everything. So this example talks about the work that we are doing in the default, some sort of default prediction or the telecom churn prediction. You don't have to worry about the exact things, but you take main things away from over here, right? Which is this. And we will have a healthy competition right now. Let's see who can build the model the fastest and can come and explain. So we will assume you have your Titanic data. Everybody has worked on the Titanic data, right? So let's say if I'm trying to do the prediction on who survived and who did not survive, everybody is clear that this is a classification problem because it's a 0-1. So 0 means non-survival and 1 means survived. So let's build a model which predicts who survived and who did not survive, right? As a factor of all the other independent variables. So what you'll be doing your outlier treatment, missing values, right? Dummy coding, all the things that you're doing for your model, for your data to be ready in terms of the modeling activity, right? Once you're done, you will do your train test split. Sorry, I mean, you'll do your features and labels first of all. Then you're going to do your train test split. No differences at all compared to the linear regression. I hope this is clear, everyone. And then instead of the linear regression, we're going to import a logistic regression model, right? Is this visible to everyone back there? Or shall I zoom in a little bit? Zoom in. Now, so instead of a linear regression model, you will now create the instance of logistic regression model, right? So going back to the 6 steps that Santosh has written over here. So we're following the same thing, but one difference that has come in. Now we'll not be importing the linear regression, we'll be importing the logistic regression. Clear? Let's carry on down then. And all of this, something you can do later on in terms of the coefficients and everything. I'll continue down. And then over here, we come to the next step, which is making the prediction. And that is not different from what we've done earlier on, right? So you will say the instance that you've created, which is a logistic instance, dot predict on the X test array. Clear? Right? So once you've done the prediction, what do you think the prediction will say? Will it have a continuous value? Will it have a probability? Will it have the classes? What do you think the prediction is going to give you? 0 and 1. So it's going to give you zeros and ones, right? Because it's a classification model. Internally, it will do a prediction of the probability, which I'll show you in the next step. But when it spits out the output, it will just give you 0 and 1. And what is the threshold it is going to use for the probability? Anyone? 50%. So if the probability of the survival is, let's say, 0.3, this person will be classified as a non-survival. If the probability of a survival is 0.51, this person will be classified as a survival. Is this clear? So that's the default threshold that we use, and it has made the prediction. Now we're coming to the last step in any modeling activity, which is go ahead and do the evaluation, right? But evaluation is not RMSE, not MAE, not anything else. We'll be doing metrics.accuracy score, which will give you the, and this is the actual, this is the predicted, this will give you the accuracy score. And similarly, we are doing a classification report and again passing on the actual versus the predicted. And then this will generate this beautiful confusion matrix that Arpan was talking about earlier. This confusion matrix, right? I mean, I'll generate that in a little bit later on, but you get this precision and recall, score, and everything else for that nature. Ignore the ROC chart right now. This is where you're going to generate the confusion matrix, which is metrics.confusion matrix, your actual, your predicted, and then we do the labeling, right? Using a seaborne heat map that we've done a number of times earlier on. And then you get this matrix, right? How does your confusion matrix looks like. And then you can go and run this, for example, which are the top variables. And you'll be doing that via the log.coefficient, something similar to the linear regression coefficients. And then you'll come back and say which are the variables, which are the most important, right? So that's the flow of the activity. I will create the assignment for this one today. But the thing is that we will not be building just one classification using the logistic regression. We're going to do today decision tree. We're going to do the decision tree hyperparameter optimization. We're going to do a random forest. And if time permits, we'll be doing a KNN as well, right? And some other algorithms on the way. So that's the flow. So create a Jupyter notebook, which says assignment 2 in class assignment 2, and then start your work. And let's see who's the first person to raise their hand to come and explain what they've done. You can bring your system. You've already built, then you are the.
I want to check.
That's okay. Let's see somebody else who would like to come, and then you can definitely come. I don't want to discourage you, but I want to give the opportunity to others also. Otherwise, they are feeling pressed under your weight or your knowledge, extreme, like, entrenched knowledge in the AIML. Or maybe I will do my random number picker. I think that will be a fair game, no? That will make everybody do their work. So you never know who's the lucky one today. Titanic. Follow the same rigor as what we did in the pre-processing class, which is dummy coding, missing values, outliers, everything like that. Your data is ready. You do your X and Y separate and all of those things. And in the meantime, I will get the random number picker ready. Sure.
Doing this, while before last week's class, there in the Titanic data, there are a lot of outliers. So I have, and none of the different features having normal distribution. I before last class, when we were doing EDA, so that time I used IQ1. Now you told it is
Flooring and capping as well.
distribution.
Flooring and capping, yeah.
Capping one. Here I have seen I have gap only where because all other I felt real value is required because you told child we cannot do
Sure.
other things also.
Yeah. Yeah.
Only fair I have.
What is the precision and recall you've got for one?
For one and recall 0.67.
7.72?
0.72.
0.72, okay.
And 0.67.
Okay, fair enough. Let's see who can beat that.
Sorry, for one recall I got 0.67 and precision 0.7 and for 0.80 recall 0.8.
Okay, fair enough.
Train test I have done 0.7525.
Okay. And Santosh, you were asking for some notebook on the Titanic, so I'm going to share that so that you can get a jump start there. Yeah, I'll share that on the Teams. I'm trying to see which one was it that I opened the other day. EDA missing values, huh? Mm-hmm. I think this is the one. So for people who lost track of their Titanic pre-processing, I'm sharing something that you may find useful. If chat is not available, then I can send it by this one email. I'll send it to Abhi by email. Abhi, you have the connector for this? This is not accepting. Like the US connector? I'm low on the power anyways. I have sent it to Abhi so he can share with you. Hmm. Thank you. Tech. Done? Aishwarya is done. How much you getting, Aishwarya? Like the precision for recall for one, for example? 0.60. Okay. And precision? 0.64. Okay. We'll take a look. We'll wait for some more time, then we can have a random number or random name actually picked to see what you've done so far.
For precision score and recall score, can we use the scale and
Yes, yeah, of course. Classification metrics. Is everyone done? Done? How many of you need more time? Some more time? Okay. Shall we do the name picking now, people? Random name picker. Everybody's ready? Okay, let's give it a spin. Let's see. Santosh. Not ready? Mohammed Iris. Not ready. Vedant. Ready? Come, bring your system. Or shall we share from there only? Can you do that? Huh? I will do that, yeah. You can share from there only. You can share your screen and then we can take it from there, yeah.
Yeah, can you hear me? Oh, sorry, 1 second.
Yes, we can hear you, Vedant.
Okay. This is so
Right.
shall I explain the steps and all?
Yeah.
Yeah, I think yeah, as part of the first part, these are the. I hope. Ah, chat. Yeah. Now it is clear, right? Yeah. I hope. So yeah. So basically, the first part, I'm just loading the database. Sorry, dataset here, and I'm just trying to see what all the columns which are available. I think there are, one second, I can just go to the info here and yeah, so there are column like a passenger ID, survival ID. So this is our output variable. And there are few input variables which are there, like for an example, P class, name, gender, age, and again, ticket fare and the cabin. And just wanted to show the database. I just downloaded it just for that one. So I have fairly 4 or 5 columns here. So based on that, we'll have to kind of take it. I'll just explain it as and when I go through it. So in the describe, I'm just trying to uh, get the statistical understanding about the data itself here. So so for an example, the age is 174. For an example, it is way too much. 714 columns are there. And there are few null and non-null values because there is some sort of discrepancies here. If you see the entire data here, it's 891. So in some places it is 714, and so we need to remove some sort of null values and if there are any present in that. So in the data cleaning process, um, what I'm trying to do here is that I'm trying to create the numerical values and non-numerical values in order to kind of perform some sort of encoding. So just I'm printing it here. So these are the numerical values, and there are certain non-numerical values as well here. Yeah. So yeah. So the unique values would be definitely the unique values which are present for this one are zeros and one for the survival. So this is what we are going to predicting it, and I would be applying some sort of encoding here and then just printing and head after that. So if you see here, the ticket.code, cabin.code, I just have done some sort of a transformation here, simple transformation onto that side. I've represented the gender as 01. So these are the things, and yeah, the cabin code and other stuff have been mentioned it here. Yeah, so that's what I'm doing it here, and post that I'm trying to uh, get kind of relationship between the relation between the two variables or more than two variables here, and uh, this is a correlationship between all the fields, and I was just trying to see this point 068 where it's a class typically. So that means the person was in which class, higher, lower, based on that. And yeah, so yeah, so there are, yeah, so based on this one, I'm trying to take P class, and then there is a fair. There was another one here in the fair. Yeah, so yeah, so I'm just focusing on P class and fair, and also I think I have taken the, yeah. So we are trying to drop the duplicates and trying to find the columns, and here I'm trying to put uh, kind of for null values, I'm trying to put some sort of imputer, like for example, I'm using medium for that sake. Yeah, so yeah, and just I have drawn the pair plot of survival versus what kind of dependencies are there. So after that, yeah, I just took this graph, but yeah, but main part would come in here, that I'm dropping these all columns because these are not necessarily important. So I'm just driving that, like for example, survival is output, name, gender, a ticket, cabin, and yeah. So, and this is my output variable. So as part of the step one, and then this is train test data, which I'm trying to pull out from the existing data itself. Yeah. So, and I'm trying to, yeah, yeah, just doing a scaling here, and then I'm applying the logistic regression. I'm just taking 500 iterations here for that. There's some issue. Yeah. So yeah, yeah, and once I run it, I think I'm getting a precision of 0.81, recall is 0.85, and F1 score is around 83. So that means the precision is that the model, how much model is correct? So around 80% is correct. Recall is uh, what what we think the model is correct, and even as a if you validate via human intervention, this is also the same. So this is what we are getting the numbers, and yeah, this is a confusion matrix which we have sort of which I have it. Yes, so that's what.
Okay. Uh, um, this is the classification matrix. Confusion matrix also you have somewhere, like the heat map.
Heat map. Mm,
Which is the same thing as the,
yeah, this is a confusion matrix.
but you're not plotting it, so
You
just
know,
do
yeah, I'm
the
not.
plotting of the part as well, yeah, that'll
No,
be good, yeah?
yeah, yeah, I've not done it. Do it.
Yeah, so just plot it. Great, thank you.
Thank you.
Round of applause for Vedant. Okay, let's pick one more number or one more name. Santosh, you chosen again. Not ready?
I was looking at your examples, so I'm.
Okay, that's fine. Sachin? Not ready? Aishwarya, you can share what you've done since you are the first one. Anything which is different in your system vis-a-vis what Vedant was talking about, definitely highlight that as well.
I hope I'm audible online.
Yes.
Alright. So here I have using IQR outliers method to remove the outliers. Basically, this method will calculate, it will focus on the middle 50% of the data set. So that how does it basically it will take the Q1 as the first quantile, which is whatever the value that fall below 25% and above 75%, it removes them as an outlier. So that's how I've implemented the outlier values. And after that, I have only taken this for the age and fair because that's the only column that I'm like having like a numerical column here. And after that, I'm also getting the dummies encoded like for the categorical value. And rest of the thing like as we do like I'll take the training X training data and then I'll fit them like I'm using a standard scalar function. From that I'm like using a fit transform to train the X data, and then I'm calling the logistic regression here, and again I'm trying to fit the model like training the model here and giving the X test scale data to predict it. So from that, we are getting the accuracy and all that. Like here, if you see that, so yeah, here is the data like we need the accuracy. Just a second. So, so yeah. So we have got accuracy of 0.72, and this is the confusion matrix. And from the data that I have, it's telling the recall score for 1 is 0.60 and precision is 0.64.
Okay, great. Any questions for Aishwarya? So two people have successfully demonstrated. Let's see if we can have a third person also. Then we will move on. Your name is not there? Okay, Sachin, you have been picked again. You ready? No? I will add your name. Whose name is not there? Let's see. So we have like, let's see anybody's name missing. Arpan is here, Aishwarya is here, Ajit, you are here, Poonam, Sunil Kumar, Karthik, Sahwar, Linton, Pawan, Santosh, Ganesh, Sai, Vedant, Abu Bakar, Tarun, Karthik, Uday, Karthikeyan, Thoya, Santosh, Rakshit, Ravi. Who's missing then? Give me your name, please. Anupam. Anupam. Full name? Anupam Srivastava. Anupam Srivastava is not there. Who else is not there? Srikanth M. Hmm? Srikanth T. Okay. Who else is missing? Rahul is missing. Rahul H. Next person who's missing? Sudhir. So you're not there. Tulbha. Is that correct? There in the screen. Acha, I'm not showing. Sulabha. Sulbha. Sulbha. Okay, Sulbha. Next. Sinha. Sulbha Sinha. Okay. Who's next person missing? Prasoon. Prasoon Ghosh. Prasoon Ghosh. Anybody else missing? Your name is there? Pavan is there already. Pavan Mandhan. Santosh, you've been picked again. Not ready? He just loves Santosh for some reasons. Pavan, you have been picked down. You can share from your side. We'll then move on after this for a break. And then when we come back from the break, we'll begin a new topic called decision tree. And then we'll spend some time talking about the concept, and then you'll build one more model before we break for lunch. Yeah, that's going to be the flow. Yeah, go ahead, Pavan.
For, I think, for age, pair, and embark, this is the age median, pair median, base, and potential joint. The sum of all the null values is zero. Okay? Everything is zero right now. Then we have to do categorical variable inputting. So for male and female gender, we have zero and one value, and for embark, I'm dropping this column and creating two more columns, which is embark Q versus S and this. And from the original data set, I have dropped the survive column because I want to train with X, and Y has only one column right now, survive. And once this is done, I've splitted the training and test data. Then this is your instantiation of the logistic regression, and then this is your fit. So this gets with X-train and Y-train. The 80% of the data is for training. Then finally, we are making predictions here. These are the scores. 81, precision is 78%, recall is 74. And this is the yeah.
Any questions? All good?
So I did two things extra.
Go ahead. You can share your screen.
Screen this is. Pass your
here, for outline. Okay, for outlier treatment here, I have not used IQR. I have written why I used only pair. Age I have not, for age I have not anything for outlier treatment, because if we do it, it may change the data, because we are changing baby to a teenager or something. Here we did it, I have done it because it was highly right speed and extreme values can dominate the models. SIPSP I have not, because again, it tells how many numbers of siblings or spouses are there. So if we change it, it will change the data. Because, for example, it is 8 siblings, will change these siblings, which is misleading and which is wrong information. First also I have not touched, because it is saying number of parents and children. If we change it, it will come like 6 parent children, it becomes maybe, it may be 3, which is wrong. So I have taken only for pair for capping. Now, another thing, what it is, same, yeah, I have used 75% of data for training, 25% of data for test. I have calculated the coefficient and I have sorted it. So I can see here, 6 is having highest coefficient, which is negative coefficient. After that, P class age, and pair, pass is having lowest one. Pair is having the lowest one. Now I have written the logistic regression equation also. Logic of P is x0 means beta 0, which is our intercept, y-intercept, and here I have written for each column what is the coefficient. So this is the regression line. Now I have added one part is error, which error means which part is not explained by the our model, and this error follows normal distribution. So I've added that part. And in prediction, whatever people shown, I have done the same thing. I have added insights also here. What I explained first, that same thing I explained here. What is recall and what is precision, all these things. Now, another thing what I did is I have drawn the ROC AUC curve. So before that, first I have predicted the probability. So why it is 1? I have because in logistic regression means from statistics point of view, it will like probability of y equals 1 given x. So it will be conditional mean of y equal to 1 given x. So that is one means survive. So it is calculating the probability of survival for this passenger. So I created this y prediction probabilities, which will be used for to compute false positive rate to true positive rate threshold. Because so to draw AUC curve, we need false positive and true positive rate, because that
We'll discuss that later on. I think people have not seen that. So probability onwards, we'll discuss post break.
last class you explained.
We'll discuss post break. So why don't we take a break, 11:35, 15 minutes. So that will be what? 11:50. So quick 15-minute break. We'll come back and then look into the probability and then decision tree onwards. Yeah. Sounds good. The good thing is it's right.